Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is 5 good problems on a specific topic of the chapter of exponents or indices, which is exponential equation. In this video, I will solve relatively harder problems on based on exponential equation. That is, we are given an equation where both the LHS and RHS are in the form of exponents, that is some base to the power to some power, raised to some power. Then how do we solve unknowns? There will be some unknown variables in the equation. We have to solve for unknown. This kind of equation is very important in your higher classes, and also will be intensely used when you will be in class 11 and 12. So I thought it would be useful if I can solve good problems on this exponential equation. So this video is part of the playlist Maths 8 Hot. Hot HOT stands for high order thinking, where I come up with relatively harder problems based on a topic as and when those topics are completed in the other playlist, that is CBSE Maths 8 RS Agarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with the 5 good problems of set 1 on the topic of exponential equation. Okay, so I have the problems PDF on the left hand side. I hope the fonts are big enough so that you can see them properly. The link of the PDF of these 5 good problems will be there in the description below. So these are all multiple choice question. Each question has 5 choice, where one choice will be correct. As always, so there are 5 questions. Try to solve these 5 questions in 30 minutes, taking approximately 6 minutes to solve each question. Only when you are stuck in solving a problem, or if you want to see my way of solution, please see my solution. And also note that there could be multiple ways of solving a mathematical problem. I will just show one way, my way of solving it, and if you have a better way of solving it, that is totally fine. Okay, now let's start solving the problem. Question number 1 says, okay, so we are given an equation. This is an exponential equation. On the left hand side, we have 32 by 243 raised to the power n is equal to 8 by 27. So the RHS is 8 by 27 and the LHS is 32 by 243 whole raised to the power n. Even though the RHS is a rational number, somehow to solve for n is the unknown. To solve for n, we have to somehow convert both the LHS and the RHS in the form of exponent, that is some base raised to the power of some number. Okay, now to solve this kind of equation, the idea is that either we can solve this kind of exponential equation. Either we have both the bases equal. Then if we have both the bases equal, then we can equate the powers, and if we have the powers same, then we can equate the bases. Okay, so as and when I will solve, I will try to explain the concept applied in solving the problem so that you can take note of them. Okay, so first see how can we convert the right hand side, that is right hand side 8 by 27 is in the rational form. Can we write it in the exponential form? So now please note that whenever you have to convert any rational number, let's say p by q, in the form of an exponent, let's say that exponent be let's say r by s to some power n. P by q is a rational number. If we want to convert this rational number to a power, that is an exponential form, like let's say r by s to the power n, where n is some integer, or it could be also be a rational number and r by s is a rational number. then it has to be then P and Q must satisfy something, that is, so we can say that P must be R to the power n and Q must be S to the power n, that is, the integers P and Q, they should be they should be expressible as a power of same power, that is, over here the power is n. So P should be expressed as should be able to be expressed as R to the power n, and Q should also be able to expressed as S to the power n. Then only we can convert this whole P by Q as some exponential form, that is R by S to the power n. So now let's see, 8 we know is 2 to the power 3, and 27 is also 3 to the power 3. So we see that both the powers 3 are same. So now we can convert 2 to the power 3 divided by 3 to the power 3 as 2 by 3 whole to the power 3. As we know that x to the power m divided by y to the power m, so this is a law of exponent, is equal to x by y whole to the power m. Okay, so we have converted the RHS in the exponential form, and we see that the base is 2 by 3 and the power is 3. Fine. Now somehow we also have to make, since the unknown is on the left hand side, the unknown is in the power of the left hand side, so definitely we have to make the base same, base on both the sides same. So somehow we have to make the base of the LHS 2 by 3. Okay, so let's see if we can convert 32 by 243 as some power of 2 by 3. So what is 32? 32 is 2 multiplied by 16. Okay, and what is 243? It has to be 243 should be we should be able to express 243 as a power of 3 and 32 as a power of 2, and both the powers should be same. Okay, so 243 is 3 multiplied by 81. So we are having this power 3. Okay, fine. Now let's simplify the left hand side again further. So 2 is 2. What is 16? 2 to the power 4. 16 is 2 to the power 4. All these small powers you should be very familiar with. What power of 2 is 16? What power of 2 is 32? All these, or what power of 3 is 81? What power of 3 is 27? All these small calculations you should be well aware of. Okay, so now 3 multiplied by 81 is 3 to the power 4. We have whole raised to the power n is equal to 2 by 3 whole raised to the power 3. Now this implies 2 multiplied by 2 to the power 4. Applying the laws of exponents, the powers get added. We have 2 to the power 5. Similarly, we have in the denominator 3 to the power 5. We are having this. Okay, now 2 to the power 5 divided by 3 to the power 5, we can write this as 2 by 3 whole raised to the power 5, and we have again raised to the power n is equal to 2 by 3 raised to the power 3. Again applying the laws of exponents. Okay, so as and when I am applying the laws, I will mention the laws. I will write the laws on the right hand side. So we know that x to the power m, or rather we know that a by we know that, okay, so this thing is already written, that is 2 to the power 5 divided by 3 to the power 5 is equal to 2 by 3 whole raised to the power 5 is already written on the right hand side, that is x to the power m divided by y to the power m is equal to x by y whole raised to the power m. Okay, now 2 by 3 raised to the power 5, this whole raised to the power n is 2 by 3 whole raised to the power, the powers get multiplied. when there is a power of power, so x to the power m, this whole raised to the power n is equal to x to the power, the powers get multiplied, that is m into n. We have 2 by 3 raised to the power 5 into n is equal to 2 by 3 raised to the power 3. Now this implies 2 by 3 raised to the power 5n is equal to 2 by 3 raised to the power 3. So now we get the equation where both the sides, the base is same, that is base is 2 by 3. Now we can equate the powers. We can equate the powers, and so we can say that 5n is equal to 3. This implies n is equal to 3 by 5. So we have found n is 3 by 5. Now the question is asking to evaluate the value of n plus 0.4 divided by 1024 whole raised to the power minus n. We know that n is equal to 3 by 5. So we will put the value of n as 3 by 5 in the given expression, and we have, now what is 3 by 5? 3 by 5 in the decimal form is 0.6. So we have 0.6 plus 0.4 divided by 1024 whole raised to the power minus 3 by 5. n is 3 by 5, so minus 3 by 5. Okay. Now 0.6 plus 0.4 is 1. So we have 1 by 1024 whole raised to the power minus 3 by 5. This is equal to, this will be equal to, if the power is negative, if the power, let's say we have an exponential term, or x to the power minus n. Now n can be an integer or it can be a rational number. If you want to make the power positive, then you have to take the reciprocal of the base. So this will be equal to the reciprocal of the base, and the power will become positive, that is to the power n. So applying this concept, you can say that 1 by 1024 whole raised to the power minus 3 by 5. I see that the power is negative. I can take the reciprocal of the base, that will be 1024, and the negative of the power will be gone. So it will be 3 by 5. Okay. Now I know that 1024, you should be aware that 1024 can be expressed as a power of 2. Now if you know of what is the power of 2, which is equal to 1024, that is fine. Otherwise you can start factorizing. Let's say it is 1024 is a factor, can be divided, the factors can be 4. Okay, let's start with 4. So we have 4 multiplied by, it is always better that you convert 1024 as a power of the smallest prime, that is 2. Anyway, I am starting with 4. So 1024 is 4 multiplied by, I guess, 256. Okay, so this raised to the power 3 by 5. Okay, this is equal to what is 256? 256 I know is 16 square. 16 multiplied by 16 is 256. So I have this. This is equal to now 4 multiplied by 16 square. What is 16? I am trying to have a common base. In this, I am trying to make the base as 4. You can make the base as 2 or even 8, whatever you feel is convenient to you. But it is always better whenever you see some number which is a power of 2, to express that as a power of 2. Even though I am expressing it as a power of 4, to shorten the calculation, but you can also express this whole 1024 as a power of 2. And the best thing is that if you know what power of 2 is 1024, I guess it is 8 or 10, I don't know, let me see. 16 square. So what is 16? 16 is 4 square, and this again square. and the whole raised to the power 3 by 5. So this is equal to 4 multiplied by 4 square and that whole raised to the power 2, which is 4 to the power 4, whole raised to the power 3 by 5. This is equal to 4 multiplied by 4 to the power 4 is 4 to the power 5, and this whole raised to the power 3 by 5. Now what is this? 4 to the power 5 and this whole raised to the power 3 by 5, the powers get multiplied. So this will be 4 raised to the power 5 multiplied by 3 by 5. This is equal to, as you can see, 5 multiplied by 3 by 5 is 4 cube. So we are finally having 4 cube, which is 64. So the value of the given expression is 64, and so the correct choice is C. C is the correct choice. Okay. Okay. Let's do the problem number 2. Solve for x. So all these questions are based on functional equation. We have to solve some unknown. Okay, so the functional equation given is 5 raised to the power 3x plus 2. So 3x plus 2 is the power of 5 is equal to 25 multiplied by 5 whole raised to the power 4x minus 1. Now clearly we can see that on the left hand side the base is 5, and on the right hand side we are having 25 multiplied by 5 raised to the power 4x minus 1. So it is very obvious that I will have to convert both the side as in the exponential form where the base must be 5. So 25 I can convert it as 5 square, and I have 5 square multiplied by 5 raised to the power 4x minus 1. So the right hand side 5 square multiplied by the product of two exponents where the base is same is equal to the same base raised to the power, the powers get added. So this will be 5 raised to the power 2 plus 4x minus 1. That is, we know that x to the power m multiplied by x to the power n is equal to x to the power m plus n. So this becomes, after simplifying the power, this is 5 raised to the power 4x plus 1. So now we have the equation where both the sides LHS and RHS are in the exponential form and the unknowns are in the power and the base is same, that is 5. So we can say that the powers must be equal. That is, if we have a raised to the power x is equal to a raised to the power y, then this will imply that x is equal to y. Okay, so we have we can equate the powers and we get 3x plus 2 is equal to 4x plus 1. So this is a linear equation in x. We can easily solve for it. So from here we can clearly see that x will be equal to 1. Hence the correct choice is B. B is the correct choice. Okay, let's do question number 3. Question number 3 says 6x whole raised to the power 6 is equal to 6 raised to the power 2 raised to the power 3. Now this the right hand side could be confusing regarding the powers. Now this is the right hand side is actually 6. This is actually 6 is raised to the power. The power of 6 is 2 raised to the power 3. 2 raised to the power 3. That is, whenever you have an expression like this, that a is base, a is some number, definitely it is not equal to 0, raised to the power, let's say if we have something like this, a raised to the power x, and there is a power of x, that is y, this actually means is that a is raised to the power x and the y is the power of x, y is the power of x. Okay, so 6 raised to the power, and the power is 2 to the power 3, so this becomes 6 2 to the power 3 is 8, so this is 6 to the power 8. Okay, so we have this. Now we see that the power are different, 6 and 8, and the powers are different, and also the bases are we have unknown in the base. So whenever we have unknown in the base, we have to make the power same. Somehow we have to make the power same. Only then we can solve this kind of function exponential equation. If the unknown is only in the base, then somehow we have to, manipulating both the LHS and RHS, we have to make the power same. Okay, what we can do, the power on the left hand side is 6 and the power on the right hand side is 8, and also we can see there is a 6 multiplied with x. So in this kind of problem, you try to I will split 6s, the whole 6x raised to the power 6, I will split this into two exponential form. That is, I will apply the concept that a p, if there is an exponential term or expression ab whole raised to the power x, this is equal to, I can split this into two exponential term, that is a raised to the power x multiplied by b raised to the power x. So the left hand side will be 6 raised to the power 6 multiplied by x raised to the power 6. This is equal to 6 raised to the power 8. Now I can see that the left hand side is having the unknown is x to the power 6, but there is a factor of 6 to the power 6. Somehow I have to cancel, I have to eliminate the 6 to the power 6. This part I have to eliminate. Eliminate meaning I have to somehow cancel this part from the right hand side. So I will have to create, I will have to somehow form this factor 6 to the power 6 from the right hand side, and I can clearly do it, because 6 to the power 8 is nothing but 6 to the power 6. 8 can be written as 6 plus 2. So this is equal to 6 to the power 6 multiplied by 6 square. So I got a factor of 6 to the power 6 from the right hand side. Now I can cancel out 6 to the power 6 from both the side, and I get x to the power 6 is equal to 6 square. 6 square. Okay. Now how do we proceed? Okay, so another concept is that whenever you have an exponential equation of this form, let's say x to the power, x is an unknown, x to the power m, where m is some integer, or let's say m is a rational number, we have x to the power m is equal to k, where k is some constant. The k is some constant. It could be constant, meaning it could be some rational number, it could be some integer, or even it could be some it could also be in the exponential form, but it is a constant. How will I get x from this equation? That is, I know that x to the power m, I have an equation x to the power m is equal to k. X is the unknown, I have to find x, where m is some m and k are constant. Let's say m and k are some rational numbers. So what will I do is, to get rid of the power m from the x, I will take power of 1 by m. I will take power of 1 by m from both the side. So that is, I will take the power of 1 by m on both sides. That is, I will do on the left hand side I have x to the power m. I will take power 1 by m. That is the reciprocal of m, that is 1 by m, and the right hand side will be x to the power also 1 by m. Now you can see that the left hand side will be x because x to the power m and whole raised to the power 1 by m, the powers get multiplied, so it will be x to the power m multiplied by 1 by m. So this is basically m multiplied by 1 by m is equal to x to the k to the power 1 by m. So this implies x we are getting as k to the power 1 by m. So this concept you must remember. Whenever you have some equation of this form, that is an unknown, it has unknown raised to the power, the power is some constant, let's say rational number, and on the right hand side is also a rational number. I will take, to find x, I will take both the sides, the power of the reciprocal of the power of x on the left hand side. So in this equation the power of x is m, so I will take power of 1 by m on both the side. Okay, so applying this concept, so in this problem we are having the constant over the k, the constant is 6 square, which is 36, and on the left hand side the m is 6. So I can say x to the power 6, I will take power of 1 by 6 both the side. So this will be, we already have 6 square, which is basically 36. I will have 1 by 6. So this implies the left hand side becomes x to the power, the power in the left hand side will become 1, because it will be 6 multiplied by 1 by 6, and this is equal to 6 raised to the power 2 multiplied by 1 by 6. So this becomes x is now equal to 6 raised to the power 1 by 3. 6 raised to the power 1 by 3. Okay. Now this is equal to actually cube root of 3, cube root of 6. So I hope there is one. Another concept is the concept of radicals. Whenever, so the concept is that whenever you have the power is a fraction or a rational number, power is a fraction, or if you have a power, let's say x raised to the power 1 by n, let's say where n is a integer, n is a positive integer, n is a positive integer. Whenever you have an exponential term like this, x to the power 1 by n, where x is some rational number not equal to 0 and n is a positive integer, then this is written as nth root of x. We call it, this is the notation is, we write square root of x, and on the top left corner we write n. So this means nth root of x. Just like you have, if there is no n in a so this means a square root. This means square root. You know, this is square root. This is square root of x. And also if you have 3, this is cube root of x. This is cube root of x. So in general, instead of 2 and 3, square root of x is actually 2, but we do not write 2. It is default. If there is no number, it means square root. So in general, instead of 2 and 3, if it is n, let's say 4, n can be 4, 5, 6, any positive integer, then it is actually the notation is this. This is the radical form, that is nth, we write a square root of x, and then in the top left corner we write n, and this is the, so this is the radical form, this is the radical form, and this is the exponential form. So we have, both these two numbers are same, that is x raised to the power 1 by n is in the exponential form. This is equal to nth root of x. and so this one, that is nth root of x, is in the radical form. So 6 raised to the power 1 by 3, we see 3 is 1 by 3, so this is a exponential form, 6 raised to the power 1 by 3, and in the radical form it will be cube root of 6. Since in the given options the choices are given as in the radical form, so the correct choice will be C. The correct choice will be C. I will possibly I will make a separate video on the exponential form and radical form of exponential and radical form of exponential terms, and this nth root with more examples and possibly 5 good harder problems. Okay, let's do question number 4. Okay, so we are having two equations. One is 2 raised to the power x plus y is equal to 128, and another equation is 4 raised to the power x minus y is equal to 16. We have to find the value of x by y. We have to find x by y. Okay. Now since in these two equations, in the first equations, we can see the x and y are unknown. Definitely x and y are variables unknown. We have to find x and y. Now possibly so you can find the values of x and y and then find x by y, or maybe you can also find directly the value of x by y. I will try to find the values of x and y separately, and then I will find what is x by y. Now so I have the first equation is 2 raised to the power x plus y is 128. Now I see the unknowns are in the power, so definitely I will have to convert the base same. The base in the left hand side is 2 and the right hand side it is a number, it is not in the exponential form. So first I will try to convert 128 in the exponential form so that it has a base of 2. Okay. So 128 is 2 multiplied by 64, which is equal to 2 multiplied by 64 is 4 cube. Okay, 64 is 4 cube. This is 2 multiplied by, now what is 4? 4 is 2 square, and this whole raised to the power 3. So this becomes 2 multiplied by 2 square, and 2 square and whole raised to the power 3 is 2 to the power 6, and now we can say this is 2 to the power 7. So I will heavily apply the laws of exponents while solving the problem. So you must be very well aware of all the basic laws of exponents. Okay, so this implies now I have 2 to the power x plus y is equal to 2 to the power 7. Both are in the exponential form and the bases are same 2, so the powers must be same. So we must have x plus y is equal to 7. So one equation we got regarding that is connecting x and y. Similarly, from the second equation we will get another equation. Let's see, 4 raised to the power x minus y is equal to 16. Now what is 16? 16 is 4 square. So now I can say that since both bases are same on both the sides, that is base is 4, I can equate the powers and I can say x minus y is equal to 2. So I have x minus y is equal to 2. I also have x plus y is equal to 7. Now I can easily solve the values of x and y. Now the way we solve, if we have this kind of two equation based on two variables, in this case the two unknowns are x and y. If we have two equations in the unknowns x and y, just like x minus y is equal to 2 and x plus y equals to 7, the simplest way to solve is that if we add up these two equations, from the left hand side, we will get a new equation. We will get a new equation where the LHS will be the sum of the LHS of these two equations, and the RHS will be the sum of the RHS of these two equations. So as we add up the LHS of these two equation, we see that y gets cancelled out. Minus y and plus y gets cancelled out, and x gets added. So we get 2x is equal to 2 plus 7 is equal to 9. So this implies that x is equal to 9 by 2. So x we have got is 9 by 2, and we also know that x plus y is 7. So we can easily find y. Y will be 7 minus x, because we know x plus y is 7. So y should be 7 minus x, and x we have already found, which is 9 by 2. So this is 5 by 2. So y is 5 by 2. So now we can say what is the value of x by y. X by y is 9 by 2, x is 9 by 2, and then divided by 5 by 2. This after simplification becomes 9 by 5, and hence the correct choice is C. C is the correct choice. Okay. Let's see question number 5. Question number 5 says we are having, it is given that 2 raised to the power x is equal to 3 raised to the power y is equal to 6 raised to the power z. Then we are asked to find the value of 1 by x plus 1 by y plus 1 by z. Whenever you solve this kind of multiple choice question, always see what are the choices. From the choices also you will get some idea how to proceed or how to solve the problem. As you can see that the first three choices are in terms of x, y, z. That is, the first one is 2 by x, the second choice is 2 by y, the third choice is 2 by z, and the fourth choice is 1. Now, you never know what will be the answer until and unless you proceed with the solution. Now, how do I solve? Now, clearly, it is asking to find the value of 1 by x plus 1 by y plus 1 by z. Now, excuse me friend, I have someone at the door. I'll be back in few minutes. Sorry friend, someone was at the door. Okay. Now, can we find the values of x and y individually and then find 1 by x, 1 by y and 1 by z? From the given equation, now, so we are having 2 to the power x is equal to 3 to the power y. If you consider this equation, then the bases are different, 2 and 3. Also, the x and y are different. Now, to solve for x and y, if the unknown is in the power, if the unknowns are in the power, the base has to be same. The base has to be same. So definitely, I don't see that I can solve for x and y or z. That is, I don't think I will be able to find the some values of x, y, and z. Okay. Now, how to proceed? Now, from the given equation, can we find somehow the value of x? Not value by value. Not some constant. Can we find x in terms of something else? So we are given this. 2 raised to the power x is equal to 3 raised to the power y is equal to 6 raised to the power z. Okay, all these three are equal. Let's say all these three are equal to k, where k is some number. Now, so I can say this will imply that 2 to the power x is equal to k. I want to get rid of x from the left hand side. So I am having 2 to the power x is equal to k. Now, also see, one hint is that 2 to the power x is equal to 3 to the power y is equal to 6 to the power z. And what is 6? 6 is 2 multiplied by 3. So somehow my idea is, can I have an expression? Can I from the 2 to the power x is equal to k, where I have assumed that all these three terms are equal and they are equal to k. So from 2 to the power x equals to k, can I get rid of x from the left hand side? So if I get rid of x, if I get rid of the power x, then I will get 2. I want to make the left hand side 2, and accordingly, and the right hand side may have some power or even some this x. Now my idea is that from this equation I will get 2 in terms of x, that is 2 should be equal to something, that something may have x either in the power or somewhere else. Similarly, from 3 we have 3 to the power y is equal to k. From this equation I want to find 3 in terms of y, that is 3 is equal to some expression, that some expression may have power y or something else. So 3 in terms of y. Similarly, from 6 raised to the power z is equal to k, I want to have 6 equal to some expression that will have z. Then I will multiply, I know I will get 2 in terms. So let's proceed. So how can I get 2 from 2 to the power x is equal to k? How will I get rid of x from the left hand side? I want to do some kind of operation definitely involving powering something, taking power of something, so that the left hand side becomes 2. As you can see, if I take power of 1 by x, on both the side, I have 2 to the power x, and if I raise whole to the power 1 by x, now please remember that when I am taking the power of 1 by x, definitely x cannot be 0. X is a non-zero number. So I am taking the power of 1 by x from both the side. So this becomes k to the power 1 by x. Now the left hand side becomes 2 whole raised to the power x multiplied by 1 by x, and the right hand side becomes k to the power 1 by x. Now the left hand side power is x multiplied by 1 by x, so it becomes 1. So I get 2 is equal to k raised to the power 1 by x. Okay. Similarly, these same steps I will follow to find to eliminate y from the equation, to remove y from the left hand side of the equation. 3 raised to the power y is equal to k. So I will take the power of 1 by y on both the sides. That is, I have 3 raised to the power y. I will raise it to the power of 1 by y, and I have k raised to the power 1 by y. So this implies it will be 3 raised to the power y multiplied by 1 by y is equal to k raised to the power 1 by y. So this implies this becomes 3 is equal to k raised to the power 1 by y. Okay. Similarly, if you follow the same steps for 6 raised to the power z is equal to k, you will see that if I take the power of 1 by z from on both sides, it will be this. this implies 6 will be equal to k raised to the power 1 by 6. So I have these three in the equation, that is 2 is equal to 2 in terms of x is equal to 2 is equal to k to the power 1 by x, and 3 is equal to k to the power 1 by y, and 6 is equal to k to the power 1 by z. Now I know that 2 multiplied by 3 is equal to 6. This implies instead of 2 I will now write k raised to the power 1 by x. Instead of 3 I will write k raised to the power 1 by y, and the 6 I will write it as k raised to the power 1 by z. Okay. Now the left hand side we can add up the powers, that is 1 by x and 1 by y. So this will be k raised to the power 1 by x plus 1 by y is equal to k raised to the power 1 by z. Now we are having an equation of in the exponential form where both the LHS and RHS are exponential terms and the base is same k. The base is same k. So we can now equate the powers and we will have 1 by x plus 1 by z, y is equal to 1 by z. So we have found that 1 by x plus 1 by y is equal to 1 by z. So this implies that 1 by x plus 1 by y plus 1 by z will be equal to 1 by x plus 1 by y. We will replace it with 1 by z. So we have this. This after simplification becomes 2 by z. So the correct choice is C. 1 by x plus 1 by y plus 1 by z is 2 by z. Okay. Now you have to practice a lot of problems on the exponents. So these problems were based on exponential equation, which is a very important concept that you must be very strong at. It will be required in your higher classes and definitely heavily used when you will be in class 11 and 12. So I will recommend that you be very strong in exponents. So this was about exponential equation. I will solve more problems, this kind of problems on this exponential equation, and then I will solve problems on simplifying exponential terms and problems related to the radical form and the exponential form. So I will do a lot of problems on this topic of exponents. So please stay tuned. These problems will be loaded in this playlist only. Once again, friend, I have someone at the door. Sorry, friend, someone was at the door. So I hope solving these problems will give you a good practice and evaluation of your concept of the understanding of exponents, the laws of exponents, and some very specific topic like exponential equation and how to simplify some very complex exponential terms, and then some miscellaneous problems. So I will be so please stay tuned for more this kind of problems coming soon in this same playlist, that is Maths 8 Hot. So if this video was beneficial, please like it, share it with your friends, and once again please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. I will end the video here. Thanks for watching, and until the next video, take care and bye.